Hello, and welcome to our Simaris Therm heat loss calculation demonstration. I'm your speaker. I'm Daniel Devine, and I work for Siemens in the UK as a business developer specializing in integrated control panels. Okay, today I'm going to do an overview of the CE and safety standards and why this heat loss calculation is relevant. We're going to do a heat loss calculation using the Simaris Therm tool. From that, we're going to generate some compliance paperwork for your technical file, and at the end, I'm going to show you where to find this tool. So, the EU directives only define the basic safety and health requirements for the product. However, safety laws govern the harmonised and non-harmonised standards. In 2016, a number of new EU directives were published and came into force alongside the Low Voltage Directive 2014. The risk analysis is an essential component of the technical file. A technical risk assessment should be carried out on your control panel. Here, you can see the Senelec Guide 32, which is downloadable from the link at the bottom of this page for free. And on there, you will be getting examples of hazards, hazardous situations, and hazardous events in Appendix C, and also documentation of the risk assessment in Appendix D. Okay, the risks of fire or impermissible temperature rise are an essential part of the safety aspects for low voltage equipment. Hence, the reason why we do these heat loss calculations and why you'll see this is useful today. Panel builders face a lot of challenges today. End users are always wanting a compact and space-saving design. They want it to be flexible, a low cost, and easy to use. Okay, but this can cause high packing density. This can also have the consequence of a temperature rise in the panel. Okay, a temperature rise in a control panel can have a detrimental effect on the products in that panel. Products can be derated, for example, or products can fail. So it's very, very important that we take consideration of this heat loss and heat rise within the panel. Siemens have many tools to help guide you at the different design, planning, engineering, and execution stages. Catching an error in the early phases would cost you a lot less than at the end phase when in testing or in use. Here is an example of how selecting the correct device can also benefit you when it comes to heat loss. Take, for example, a motor, 1.5 kilowatt, 3.6 amp. There's two possible motor starter protectors we could use in this instance. 2.8 to 4 amp, that's within the range, and a 3.5 to 5 amp. The cost differential between these will be very little, if any, but the motor starter protector power loss is about 40% lower at the lower setting than at the high setting. So choosing the 3.5 to 5 amp breaker here would benefit you. Stated in the 61439 standard is the 80% rule. Okay, so this refers to a diversity factor, okay, an assumed load of the motors. So motors under 100 kilowatt can have an assumed load of 0.8, hence the 80% rule. Our tool, the Simaris design tool that we'll look at today, will take this into consideration. So when we look at the formula for power, P equals I squared R, this 0.8 times 0.8, 0.64, we can get a lower value as opposed to, for example, if we used a spreadsheet to do this calculation or another tool, we might come out at 100%. So you're getting a very high watt output, whereas using our tool, it's more to the standard. So you're within the standard and it will be a lower value. Okay, before we jump into a calculation, just to give you a scenario. Okay, we've had both sides of the scale when it comes to customers of ours doing calculations, where some customers, or a lot of the customers, if they don't do a calculation, some customers assume which fans or which heat dissipation method they're going to use on their panel. So for example, we've seen customers put in a fan on each panel. And when we've actually done the calculation afterwards, we found that one of those fans would have been enough for the heat loss. Now we've also seen it at the other side of the spectrum where customers have had product failures or products just stopping to work in their panel. For example, a drive. And when we've done a calculation on the products that are in there, we found that the fan or the air conditioning unit was very much undersized, and hence they had this problem. So as we mentioned earlier on one of the slides, it's best to do this in the planning stages rather than after the panel has been designed. Okay, so on our screen, we can see new project or open project. So if there's one that you're working on and you've saved it, you can go ahead and open it. We're going to look at a new project. Okay, project definition. This is where we define our project and who's doing it. As you can see, the created date and time is not amendable, but the rest of it is. So for example, we can give the project a name, we can reference it, we can put the author's name in and make any amendments here. As we can see, there's 4 elements to this calculation. System planning is our next phase. In the system planning, we will select a box. Is it a Siemens Alpha box? Is it a Siemens Civicon box? If not, if it is, great. If not, we can go ahead and select this freely definable enclosure. So if, for example, you're using another metal manufacturer or panel manufacturer, we would go ahead and select this example. Double click in. And now we're at the phase here where we're going to select if we're doing an easy calculation or if we're going to do a calculation according to a safety standard. This is the best option here to select because it'll give us more functionality. The type of installation. Where is our panel going? Is it going to be against a wall here? Or is it back to another panel? Is it freestanding? For this example, we will select a wall. The height of the final site. If this was going to another country like North America, for example, with a high altitude, you might want to change this. Simply drop down the box here and select that from the options. The surrounding temperature. This is a very important element to the heat loss calculation. If this is a calculation for example, a panel in the UK and the ambient temperature of the room is 23 degrees, then great, we can leave it here. If it's going to a hotter country, like India, for example, we're going to want to change this to reflect the surrounding temperature where this panel is. For this example, we will leave it at 23. Now, down here, we're going to double click into our freely defined enclosure. And here, we're going to define the distribution cubicle. Okay, we've got different degrees of protection. We've got different protection classes. And we've obviously here got the height, width, and depth, which we are going to define. Okay, the project I'm looking at today was an example where we had a 600 mil width, 600 mil depth, and a height of 2000 mil. Here's our rated diversity factor that we spoke about earlier. This will be applied to any motors rated under 100 kilowatt. We've also got a wiring factor in here that needs to be considered. This tool will do it automatically. The lining up of our panel. Is it standalone? Is it on the left end, in the center, on the right end of a set of panels? Again, this is going to affect the heat loss dissipation. What's the temperature inside the panel? This is again very important. Okay, so the optimal temperature I would recommend would be 35 degrees. Okay, a lot of our products, Siemens products, are rated for higher temperatures, but not all products are. So, for example, a power supply that is the heat rating of that is a lot lower than some other products, i.e., like a contactor. Okay, we're going to calculate this for the full height of the panel. Okay. So now we've defined our panel, we're going to go ahead and put our devices in this panel. So here you can see here, this tab here, we're going to select this, devices. Okay. So there's numerous ways of doing this. So starting with the order number. Do you know the Siemens part number? This tool contains tens of thousands of Siemens part numbers. Do you know the part number of the device you wish to add? Take a contactor, for example, 3RT2015. Once we start typing the number, it will give us all the different options. Okay. Then once we find the product we're using, double click, and here it will be added into your panel. You can now change the quantity to suit and continue to add your other parts. We will remove this. If you're doing a panel that is mostly Siemens, but there may be another manufacturer's product in there, we can add that also. Click on here, File, User-Defined Device. This box will appear. Here we would just click for a standard device, i.e. a component such as a soft starter or a contactor. We would just click New Device and then input the information. If you download any manufacturer's spreadsheet, you should get the name of the device, the number of poles, and the nominal current and power loss data from a spreadsheet, from the datasheet. We can also add fans or air conditioning units or heat exchangers from other manufacturers also. However, there are other ways of adding. Here we've got the option of import. Okay, so we can download a CSV template or an Excel template. We download the template and it will look like this. Here's an empty template. As you can see, number here is where we will put the part number. All the other data here, although it's asking for number of poles, nominal current, power loss, these can all be ignored. As long as you're using Siemens products, all you need is the part number and the quantity. Here is an example. Now we've got all the Siemens part numbers and some other manufacturers, and we scroll across here and we have the quantities. No other data is required. Close this. And now we will upload this file. So choose a file. This will just take a second to load. As you can see, all of these products have been imported. If you get a notification here to tell you that a device has not been imported, you will need to investigate. This one here is an auxiliary on a miniature circuit breaker, not relevant. But if one does not import for whatever reason, quite simply, you can go through the same process as we did with a competitor's product. Go to User-Defined Device and create a new device. And that will then be visible here in your custom devices. Okay, as you can see, I've built up some parts myself. Okay, so now I'm happy. I've defined the size of my distribution cubicle. I've got all my devices in there. As you can see, this devices, we've got switches, contactors, we've got circuit breakers, miniature circuit breakers, power supplies, distributed I/O. We've got drives in here. We've got 6 drives, G120C Siemens drives. We can also, if we want, add bus bars. Okay, simply select the cross-sectional area of the bus bar you're using, the number of poles, and then you can amend the length. For this example, we won't do it. Okay, I'm now happy. I've got my distribution cubicle defined. I've got my devices. I'm now going on to the calculation. So I'll click here, calculation. Okay. Here, we now have our calculation done. Let me just make you see this. Okay. So we can see now here the effective power losses of all circuits cannot be dissipated by the enclosure alone. We need some intervention. Okay, we can see here the total power loss of the products, and we can also see now the total power loss based on our 80% rated diversity factor. Now, a neat little feature here, top bottom right, temperature rise characteristic curve. If I click here, we can see the temperature in this panel, 1 being the top, 0.755 being the third quartile. So it's broken into quartiles, but we can see the temperature in this panel will rise up to 68.8 degrees based on the 5 or 6 drives, the circuit breakers we had in this panel. So that's not healthy, and that's not where we want this panel heat temperature to be. Okay, so what can we do about this? Air conditioning of the enclosure. Let's click in here. We've got some options. You can look at a fan, an air conditioning unit, heat exchanger. Well, for this example, I want to look at a fan, and I'm going to position it in the door of the control panel. Here we have order numbers of Siemens fans. However, as I said earlier, you can add a different manufacturer's fan if that's your so desire to use. And here, as you can see here, the description of the fans. These are all typical fans or standard fans that you will see in the market. For example, 25 cubic meters per hour on a cutout size of 92 by 92 mil. And we can scroll down here and continue 250 cubic meters per hour on a cutout of 2333. And these go all the way up to the very strong 930 cubic meters per hour cutout 292 by 292 fans. Now the clever thing about this tool, as we can see here on the right hand side, I'm going to scroll across, is it's showing the cooling capacity of these fans in our panel. And here we know we need to dissipate 526.7 watts to be within our 35 degree temperature. So how are we going to do that? Let's have a look. This one will not suffice. If we scroll down, if we want to use just one fan, great, we can use one of these, 619. If we wanted to use 2 fans, we could have a look at these if we wanted. I'm going to put one of these fans in, a 160 cubic meters per hour on a cutout size of 223 by 223 with a cooling capacity of 619 watts. Change the quantity here from 0 to 1. Okay. Now you can see the effective power loss of all circuits can be dissipated by the enclosure. Let's have a look again at our temperature rise characteristic curve. Great. Up to the top final height of the panel, the temperature 26.9 degrees, 27 degrees. I'm more than happy. Okay. Now what? Now we're going to generate some paperwork, some compliance documentation. Click on this. First of all, we need to save the project. So we can save as. We can save as YouTube. And now we can get our output. We may want to finish the project first before we select our output. So if you're happy and you're finished, go ahead and click on the finished product. And then we can click on output. Again, we'll be asked to save it. Once saved, this is what your compliance paperwork now looks like. We've got our project name and our reference ID, who did the calculation, when they did it, exactly what it is. Let's scroll down. Okay, so we can see the system that we selected and the type of installation. We can see the distribution board and how we've defined the sizes. The rated diversity factor and the wiring factor is also mentioned. The temperature inside the enclosure, and all of the total power loss and Kelvin details. If we scroll down further, we can see all of the products that we added, the circuit breakers, the drives, the power supplies. And then we can see here the fan that is dissipating the heat and the cooling capacity of that fan. Further down, we can now see the effective power losses of all circuits can be dissipated by the enclosure. And further still, we have our nice temperaturized characteristic curve, and more details about the calculation. This can now be printed off or copied and sent to your customer as evidence of a heat loss calculation for your control panel and why you have sized the fan and the heat loss dissipation method or air conditioning unit as per the standard. Thank you. As promised, let's look and see where we can find this tool. Okay, there are two places that I can show you, but I want to show you the control panel page today also. So if we look at siemens.com/control panel, here we have got a lot of control panel topics for you to look at. We've got webinars that you can watch on demand, or you can sign up for our newest and up and coming. As you can see, as I scroll through, we've got all the topics that your control panel needs are all covered. Okay, if I keep scrolling down, we have this neat area here to Info Center. If I click here, you can scroll down and we've got each of the topics under a heading. Click on that topic, for example, European International IE Directives. We've got white papers and technical manuals on all of these areas. Tools and electrical engineering. We've got some great free tools here to download. The tool we looked at today, Simaris Therm, just click on this link and you can download it. We also have another web page. On here, you can download the Simaris suite, which will include Simaris Therm and other great planning tools. Simaris Design, Simaris Project, Simaris Curves, for example. Simply click here to download. I hope you enjoyed this presentation today, and please get in touch if there's anything that I or anyone at Siemens can help you with. Thank you for your time.